Welcome back, ladies and gentlemen. Today we're talking about using more than one transformation, so let's get right to it. The two ways I plan on trying to go over these, and these are two separate ways, or you can mix them if you want to, but we're going to be working directly with the coordinates, and we're going to be working on the graph. What does it look like? These are two separate tactics or strategies to be able to solve this problem. Let's get to it. So we're going to dilate the trapezoid with respect to the origin using a scale factor of 2. 2 is bigger than 1, so we're making it bigger. That's what this whole sentence says. We're making it bigger, and we're doing it by 2. So what that means is I'm taking this 2 here, and I'm going to multiply it by every number that I see. There's 4 vertices. That means there's 8 numbers. It means I have to do 8 multiplication problems just to make this bigger. So let's do that. 2 times negative 2 is negative 4. 2 times negative 1 is negative 2. 2 times negative 1 is again negative 2. 2 times 1 is 2. 0 times 2 is 0. 0 times 2 is, 2 times 1 is 2. I'm getting way too fast. My brain's got to catch up. And 0 times 2 is 0. 2 times negative 1 is going to be negative 2. This is the points I have from the original to dilate. So I've done the first step because here's the first transformation that's done. Then I need to translate 6 units right. So right is positive and x values. And the 6 is just the number we're going to do. Then 2 units up is positive and y values. And 2 again is the amount we're going to. So what that means is we're going to take this 6 and add it, because it's positive, we're taking this 6 and adding it to all of our x values. So if we take 6 plus negative 4, that's going to give us a positive 2. If we take 6 plus a negative 2, that's going to give us a positive 4. And if we take 6 plus 0, we're going to get 6. And if we take 6 plus 0, I'm going to write it up here, we're going to get 6. So that means the image of A, the image of B, the image of C, and the image of D, we've already got our x values for. We've still got to go 2 units up. So I'm going to take this 2 and I'm going to add it, because it's positive, to each y value. So 2 plus negative 2 is 0. Then 2 plus 2 is 4. 2 plus 2 is 4. Oops, forgot to close that one. And 2 plus negative 2 is 0. So what this tells us is we now have all the coordinates we need, because here was the original negative 2, negative 1, here's A, and negative 1, positive 1, here's B, 0, 1 was C, and 0, negative 1 was D. So playing connect the dots, here's my shape. And then the image is going to be at 2, 0. And that's after we've dilated and after we've translated. So this was the second transformation. So 1, 2, so A prime, or the image of A, goes here. B is 4, 4, 4, 4, so B prime. 6, 4 was C, and 6, 0 was D. And there is our image. Now, how we would have done this by just trying to use the graph, and apparently the ink did not dry as quickly as I thought it would be, is we would have to think of it in terms of starting this and what the image after dilating would look like, because we have the image here of the original, and we have the image after the dilation and the translation. So we need to have a picture of what it looks like when all we do is the dilation, kind of as that middle ground. Had to go get a pen real quick, so now that I'm back, let's get the dilation drawn on here. So remember, the dilation we already had figured out. We had figured out the coordinates in between. So what I'm going to do is I'm going to actually change those to be red to make it a little bit more clear which one is which. So if I do that at -4, -2, this would have been another A. At -2, +2 would have been B. At 0, 2 would have been C, and 0, -2 would have been D. So if I were to draw just the dilation of our original, it would have been A. And then I can verify that I go 6 units to the right. So let's take D. 1, 2, 3, 4, 5, 6, and then 2 units up. 1, 2. I should end up there, which I did. Then I can know that A here should have been 1, 2, 3, 4 to the left, and 1, 2, 3, 4 to the left. C should have been 1, 2, 3, 4 up, 1, 2, 3, 4 up. B is 1, 2 from the left of C, and boom. We see that first we can dilate it, and this guy shows up, and then we moved it, and that's actually what we did by doing all, or using just the coordinates. Now, the other way that we can go through and maybe write this down so it's a little bit clearer as coordinates is if we start out as A, -2, -1, B is going to be -1, +1, C, and I'm probably going to run out of room for D, so I'll do D hopefully somewhere down here, but at least you should be able to get the idea of what's going on here before I do it. Doesn't mean D doesn't exist anymore, it's just possibly off frame. I'm going to try to include it. 0, -1. Let's see how I did. Sorry for the shaking. I'm getting alerts and having to get rid of them. All right, everything's on there. So what I do first is the dilation was I multiply by everything by 2, because a dilate changes everything. And yes, I know I'm not supposed to be using X as multiplication, but right now it's meant to be shorthand. And what I can do is then when I do that, when I did these, I got -4, -2, then I got -2, 2, I got 0, 2, and I got 0, -2. Then I need to add 6, remember add 6 to all my X values, because that's what left and right movements are, X values only. And then I needed to add 2 because I had up 2, which is adding 2 to all my Y values. So when I do that, I end up with my image of A is -4 + 6, again, or sorry, it's a +2. Let me get rid of that. I got ahead of myself. This is 4 and 4. This is the image of C, which was 6 and 4. And the image of D, which was 6 and 0. And these are my final coordinates by taking a dilation here, or K equals 2, and a translation here of 6 right and 2 up. So this line is all dilation, this line is both movements, right and up, to end up with our final coordinates. So this represented what I did vertically here. Going up, this is the same thing as that. This was not a third way of doing it. This was more of a right out way to see what I was doing each time here. And this is by the graph. We first dilated it, and then we moved it, and we would have ended up here. In both cases, whether we do it on the graph or we do it by the coordinates, we end up with the exact same points. So those are the two methods. We can do this on a graph, where we first dilate, then we move right, then we move up, or you can use the coordinates to dilate by 2, because you multiply everything by 2. You move right by adding 6 to all the x values. You move left by adding 2, or sorry, you move right, up, you move up by adding 2 to all the y values. What I was thinking was to move left, if this said units left, you would actually subtract, because that's a negative movement. If you're going to move down, that's a negative movement, so you would subtract here as well. But we moved right, which is positive or adding, and we moved up, which is positive or adding as well. Now pause the video and copy what you see on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but add it to your notes to make them yours. Remember, you're in school to learn. So when you're learning, it's all about understanding the process, never just about the answer. We'll see you tomorrow.